So Birch reduction of these will give you this. But how? Calm down, because chemistry is mystery and you have to solve this mystery to understand the. And I will expose all these. So first of all, Birch reduction of internal alkyne will give you trans product or trans alkane. But why internal alkyne? Why does terminal alkyne not give Birch reduction? And second question, why trans product? First of all, internal alkyne in which carbon-carbon triple bond do not present at the end of the carbon chain. Then terminal alkyne in which carbon-carbon triple bond present at the end of the carbon chain. Here is the example. In terminal alkyne, hydrogen connected with the sp carbon can be easily removed due to the polar nature of CH bond, resulting in a formation of alkynide ion. And this alkynide ion reacts with the metal from the solution and resulting in a formation of alkynide salt. So, terminal alkyl cannot give Birch reduction. Answer of the first question. So, electron will attack on any of the sp carbon resulting in a radical anion. Here you can see there are two lobes. One lobe have two electrons and another have one electron. So there are two possible structure of radical anion. One will give you cis product and another will give you trans product. In cis product or cis radical anion, two lobes are parallel to each other and electron will repel each other. Due to this, radical anion will be unstable, and in trans radical anion, both lobes are far from each other and there will be less repulsion between electrons. So trans radical anion will be more stable and Birch reduction of internal alkyne will always give you trans product as a major product. Answer of second question. But what will happen when I rearrange the structure like this? Birch reduction of conjugated double bond will give you alkene. First of all, electron will attack on the first sp2 carbon, resulting in a radical anion. It will combine with the proton from proton source like ammonia, resulting in a free radical. Again, electron will attack on free radical, resulting in a anion, and it will combine with the proton from proton source, resulting in a alkene. But what will happen if I add oxygen here? Birch reduction of alpha beta unsaturated ketone gives you saturated alcohol or saturated ketone depending on the condition. If you use small amount of alcohol or ammonia as a proton source, you will get saturated ketone. And if you use more amount of alcohol, you will get saturated alcohol. First of all, electron will attack on the double bonded carbon, resulting in a radical anion. This radical anion combined with the proton from proton source like ammonia or small amount of alcohol, resulting in a free radical. Again, electron will attack on the free radical, resulting in a anion. This anion will rearrange itself, and you can see the structure after rearrangement. Enolate ion, in which oxygen have negative charge, which will make pi bond with carbon, and then C pi bond will break and carbon will get negative charge. After workup, you will get saturated ketone, or reaction with alkyl halide gives you ortho substituted product. But you will get this product if you use ammonia or small amount of alcohol as proton source. But if you use more amount of alcohol as proton source, you will get saturated alcohol. For this, let's go into the Birch reduction of. So Birch reduction of saturated ketone will give you saturated alcohol. So let's go into the mechanism. First of all, electron will attack on the carbonyl carbon, resulting in a radical anion. This radical anion combined with the proton source like alcohol, resulting in a free radical, and then free radical will combine with the electron, resulting in a anion. Then this anion will combine with the proton, resulting in a saturated alcohol. You can also see the mechanism in chair form. But remember one thing, that OH group must be at equatorial position, because trans product will be more stable than cis, because in cis product there will be 1,3 diaxial interaction. Similarly, styrene gives this. But how? Alkene and benzene ring. Most stable part is benzene ring. So first of all, alkene will undergo into the Birch reduction and then benzene ring. Mechanism is simple. Birch reduction of ether will give you this. But in case of amine, I know you will give answer like this, but you are wrong. Birch reduction of amines will give you conjugated product. Yes, you can get conjugated product in case of ether also, but by using acidic condition. But in case of amine, it will convert into the conjugated product. Let's go into the mechanism. First of all, electron will attack on meta position, resulting in a radical anion. Then after accepting proton from proton source like alcohol, resulting in a free radical. Then electron will again attack on free radical, resulting in a anion. And after accepting proton, resulting in a cyclohexa 1,4-di-1-amine. But lone pair of electron and nitrogen will make pi bond with carbon, and CN pi bond will break and carbon will get negative charge. Then proton transfer and then conjugated product. But what will happen if I add carbonyl here? Birch reduction of carboxamide will give you aldehyde. Let's go into the mechanism. First of all, electron will attack on carbonyl carbon, resulting in a radical anion. Then after accepting proton from proton source, free radical. Then electron will attack on free radical, resulting in a anion. Then after accepting proton, resulting in a product. This product will hydrolyze, resulting in a diol, in which two OH group are at same carbon. So this molecule can be easily dehydrated and resulting in a aldehyde. Similarly, Birch reduction for Ester, Nitro, Nitrile, Epoxide, Thioether and Halide. I am not giving mechanism because these are simple reduction process. But for phenol, Birch reduction of phenol will not give any product, because generally in solution phenol is present as a phenolate anion. So after attack of electron, we will get a radical dianion, which is unstable. So phenol and phenolic ring like 1-naphthol and 2-naphthol will not give Birch reduction.